this video, I'm going to be covering question 1, part D from the 2018 AP Calculus AB free response calculator required portion of the test. I cover A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out those other videos. Alright, so looking at D, we are looking at this interval from 0 to 300, and they want to know at what time t is the number of people in line at a minimum. So what we're being asked here, because we've got bounds on here, is we're really being asked to find the absolute minimum of this problem. So the absolute minimum process, absolute max, absolute min process, it's a step-by-step process that we follow every single time. What we do is we need to first come up with an equation for what our total amount of people is going to be at any point in time. Well, we came up with that equation back on part B when we were trying to find out how many people are in line for this escalator at t equals 300. The formula for that you would take, we'll talk through it again here, you would take your initial amount of people and then you would add to that the total that enter the line and subtract off of that the total that leave the line. And so for us, what we found back on part B was we started off with 20 people in line. So we've got this initial amount here of 20 people in line, and then we've got the total amount that enter comes from our entering equation. And because we're talking about 0 to 300 on this piecewise function, we're going to be using just this top equation right here. So this is the amount of people that entered the line. So we were adding to this the integral from, this time we're going to go 0 to t because we don't know when that period of time is. Back on B, we plugged in 300 for that t, but on this problem, we don't know what that time amount is, so it could be sometimes 0 to t. The total entering is going to be that top equation, so 44 and then t over 100 to the third times 1 minus t over 300 to the 7th. And we subtracted off of that the total amount of how many were leaving. And so that was telling us that people are exiting at this rate of 0.7. So this was minus 0.7, and then we have this dt right here. So we didn't call it t of t, which is what I'm going to call it now, the total amount at any given time, but that's what we're going to use it in this problem for our absolute minimum process. So I say, okay, I've got 20 plus the integral from 0 to t of this equation here, t over 100 to the third, 1 minus t over 300 to the 7th minus 0.7 dt. So step 1 of your absolute max min process, and this is what I always tell people, you have to just have these processes down to a step by step and follow them when you run into them. And the natural steps, you just have to do those steps as they ask for them. So step 1 of this process would be to find the derivative of this equation. So I would do t prime of t. I'm essentially ddt'ing both sides of this equation. So I ddt that and I ddt that. The 20 goes away. The derivative of a constant goes away. When we look at this second piece here, this is that fundamental theorem of calculus part 1. Derivatives and antiderivatives are inverses of each other. They cancel each other out. It's like squaring a square root, right? When you do that, they cancel out and whatever's inside there comes out. Well, same idea here. These pieces are going to cancel out, and this t is just going to drop into the formula everywhere I see it. So this would be 44 t over 100 to the third times 1 minus t over 300 to the 7th. Then this is still a part of the antiderivative here, so it doesn't go away, but it doesn't have a t, so it's just going to sit there at minus 0.7. Then step 2 of the process is we need to go find critical values. So critical values occur when our derivative equals 0 or our derivative is undefined. And so we're going to set this thing equal to 0 right here. And then we are going to solve that out. Well, lucky for us, this is a calculator required portion of the test. So we can actually do this piece in our calculator pretty quick and easy. You'll take this equation here, you'll put that into y1 on the calculator. You'll take that equation there and you'll put that into y2 on the calculator. Then from there we'll graph those, and we're then going to do a second calc, and we'll choose the number 5 option in that menu, which is intersect. The place where these two graphs intersect or where they're equal to each other, and that's going to give us our critical values. So we open up our calculator, go to our y equals. Because we've done a and b already, we should still have that same equation already in our calculator. Don't use that clear button until you look and see what you've got in there, because we have what we need. We've got what we need in y1, and all we need to do on this one is just add 0 into y2. So we graph this, and we can see along the bottom that red line cutting through there. So it's that point on the left where it hits and that point on the right where they intersect that I'm going to go calc those two intersects. So we go back in. I'm going to do a second calc. I'll choose that number 5 intersect option. It's then going to ask me a series of 3 questions. The first 2 questions I could really care less about. It's going to say, is that the first curve? Yep, that's the first curve. Go ahead and hit enter. It's going to switch automatically to the second curve for us and say, is that the second curve? Yep, that's the second curve. Go ahead and hit enter. It's this third question here, the guess, that you have to pay attention to. So the guess just means get me close to the intersect you want to find. So I'm close to this one on the right, so I'm just going to go for it first. I just scroll my cursor so I'm close to that intersect, and I hit enter a third and final time. It says the word intersection at the bottom of the screen, and so I go ahead and grab that. And when I'm grabbing points before it's my final answer, I go ahead and grab the full value through this whole thing. So then that first critical value is going to be x equals, or at least take it out as far as you can. If there were 6 decimals, I'd go that far. 166.574, and then 72, I believe, at the end. So that's our first critical value right there. And then we're just going to start the process over to find the other critical value, that other intersect. So I hit second, calc, and again, choose the number 5 option, intersect. First curve, again, just hit enter. Second curve, just hit enter. And then guess, I'm now going to scroll all the way back over here to find out that answer. And I hit enter again. And it gives me my second critical value, so x equals 33.013298. So x equals 33.013298. So these are now our 2 critical values. And we go on to step 3 of this process. So step 3 of the process is we are going to plug in all of our critical values and the endpoints of our interval. So the endpoints of our interval are 0 and 300. So we're going to go t of 166.57472. We'll get a value out for that. We're going to do t of 33.013298. We'll get a value out for that. We're going to do t of 0, that's our endpoint, and we're going to do t of 300, that's our other endpoint. So these two are our critical values. These are the endpoints of our interval. And so we're going to plug all of those back into this original function up top here. So this would be 20 plus the integral from 0 to 166.574. Oops, that's... Let me get that all right for us in here. 574 point, or we already got the 0.72, and then of that equation. So 44 t over 100 to the third times 1 minus t over 300 to the seventh minus 0.7 dt. To do that, when we go to do this portion here to get this integral piece out, so when we're looking to just find the integral here, we can do that in the calculator, right? We did that back on part B. So when we want to get those values out, step 1 is you're going to put that equation into y1, which we already have in there. And then we're going to go ahead and graph that. And we'll do a second calc, and then we're going to choose that number 7 option in there, which is integral of f of x dx. It's going to ask us for a lower bound, it'll ask us for an upper bound, and then from there we'll enter those values and get out what it is for that piece. So back into the y equals, I'm going to clear out the 0. Oh, I just cleared out my full equation. That happens sometimes. So 44 parentheses x divided by 100, and then close it, raise it to the third, and then multiply that by 1 minus, get a fraction again, x divided by 300, close that, raise that to the 7th, and then minus 0.7, and then go to the down and hit clear. Be careful on hitting clear too fast. I just told you to do that in an earlier video. But so we graph that, and now we're going to go second, calc, and we'll choose the number 7 option, integral of f of x dx. Our lower bound on this is 0. Our upper bound on this one was that critical value, 166.57472. We hit enter. Tick, 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 tick. Jumps through there. We get 138.070. Don't forget that you're going to need to add 20 to whatever that is, because that's going to be, we had that a constant 20. That was our starting amount. So we add 20 to that bottom of the screen, integral of f of x dx. So we're going to end up with 158.070. So this top one is 158.070 people. We play the same game for the second piece here. We're again going to do 20 plus, and then this time the integral is going to go from 0 to 33.013298 of that full equation again, right? So all of that that's already in our calculator, minus 0.7 dt. So don't hit clear, right? Go, it's already there. We hit the graph button. We go second, calc. Number 7, integral of f of x. The lower limit on this one is 0. The upper limit is our other critical value, 33.013298. Oops, I forgot the 1 in there. Sometimes your fingers move faster than you can type. 298. Hit enter. And out of there at the bottom we get negative 16.196656. So we're going to need to take that negative 16.196656 and we're going to add that to 20. So if you want to, you can write it down. The other thing you can do is that is the stored answer in our calculator right now. So if I go back out to the home screen, that integral answer is our answer, and we just add 20 to it. And that's going to get us 3.803. And now we come through and do the last piece. So then we've got 20 plus the integral from 0 to 0 of this huge equation. Writing it all out for you just to let you know that this is what's happening, even though you've seen it a bunch. The key on this one here is recognizing that your upper bound and your lower bound are the exact same number. When your upper bound and your lower bound match each other, the answer to any integral problem in that situation is 0. It doesn't matter what the number is. If your upper and lower bound match, then that whole section there is just going to equal 0. So then we have 0 plus 20, and we get out 20. Then t of 300, that's actually what we did back on part B here. We plugged in 300 for t. You could grab your answer from up above. That would have ended up equaling 80. But if you needed to, again, you just go through the process. This would be 0 to 300 of this full equation. All of that. Shove that into the calculator. We would have gone in. We would have graphed it. Second, calc, integral of f of x dx from 0 to 300. Scroll, scroll, scroll. It's taking its time. It's getting there. We get 60 on the bottom. 60 plus 20 gets us 80. So from here, we now just compare these values, and whichever value is the smallest value, that is going to be what our absolute min is. So the smallest value on this one is happening at 3.803. That's happening at time 33.013. And so what we want to do is, they want us to round to the nearest whole number. So our final answer out of here, we would say our final answer is at T equals 33.013. We have the smallest number of people in line, or you could say the minimum, which is rounding 3.8 up. We would round that up to 4 people. So again, this is an absolute max-min style problem, which is going to require us to use that fundamental theorem of calculus, part 1, to get our derivative. But process-wise, you follow that absolute max-min process and get out your values for your critical values, plug in your critical values and your endpoints back to the original equation. The smallest one in this situation was what we were looking for, so 3.803. So this problem, we would have gotten 1 point for finding our critical value equation set up here. We would have gotten 1 point for finding out that that was when the smallest amount happened. We would have gotten 1 point out for the number of people. And then the justification, which is all that work, they would have given us 1 point for all that work. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.